Hi, my name is Varun, and this is my presentation on Lab 1, dealing with charge tape. So to start off, charge is a property of matter just like mass. In SI units, it is measured in coulombs and is a scalar quantity. Charge is also conserved in a system, and this is a property that is taken advantage of in this lab. And finally, like charges repel, while opposite charges attract. So in this experiment specifically, our goal was to determine the amount of excess charge on a piece of tape. And this was done by first determining the sign of the charge, so positive or negative, and then obtaining a rough estimate of the magnitude of the excess charge. Finally, our result was that the tape is positively charged with a tape charge of 4.18 times 10 to the negative 9th coulombs, representing a deficiency of 2.6 times 10 to the 10th electrons. And then the ratio of the number of deficient electrons to the number of atoms is roughly 8.1 times 10 to the negative 8th. So the way the U-tapes were made was relying on conservation of charge. So when the two pieces of tape are stuck together, it is totally neutral. However, when separated, some excess charge on each piece will exist. So the next thing that we had to do was make some initial observations. So first, I noticed that the U-tape was attracted to my hand. Two U-tapes repelled each other as expected, since they should have roughly the same magnitude and sign of charge. And then next, a charged U-tape was attracted to a neutral object, which is expected, as expected. Next, we determined the sign of the charge of the U-tape, and this was done by using a charged object with a known sign. In this case, it was a plastic pen rubbed through hair, which was known to have a negative charge, and this attracted the charged U-tape. Therefore, the U-tape was positively charged. To determine the magnitude of charge on the U-tape was slightly more complicated. What we did was set up an experiment where we would try to float a U-tape that was balanced in the air. In this situation, we had to make some assumptions, and there were some key features that are worth noting. When the tape is balanced, the force of the weight from tape B is directly offset by the electric force exerted by tape A. In other words, they're in static equilibrium. Both are U-tapes of equal length, so they have the same charge magnitude and sign and should repel. Each U-tape could also be reduced to a single point charge. Finally, the free body diagram is shown to the right with only two key forces, the weight and the electric force. All other forces and players such as air resistance were negligible in this case. So here are some calculations. The mass of the U-tape was about 6.16 grams. And they reached equilibrium at around 1 centimeter away from each other. The U-tapes were believed to have the same magnitudes as they were the same length. And so doing some math, we found that the charge of the U-tape was as shown right here. Here was a model made in Glowscript to show the same situation. The magnitude of the electric force is directly offset, or about exactly, by the electric force. Here we did a few more calculations where we found out the ratio of the number of electrons deficient to the number of total atoms. So one key assumption made here was that an atom was a circular cross-section which took up 100% of the area of the tape with no gaps. And then the calculations were done as shown. So some final thoughts were that if electrons were positively charged and protons were negatively charged, nothing would fundamentally change other than the sign of the charge of the U-tape. And lastly, during this lab, handling the charged tapes as little as possible was important because our skin is an excellent conductor and can quickly neutralize any excess charge on the U-tape, rendering it useless for the experiment.